Victorian England thrummed with industrial splendor and brass-bound telegraph wires. In London, a meticulous amateur astronomer, Richard Carrington, kept a close watch on the sun from his Red Hill Observatory in Surrey. Born in 1826 and trained in banking, Carrington made careful sunspot sketches and measured solar brightness at a time when solar physics was still a nascent experimental discipline. The era's global telegraph network, strung across Britain, Europe, and the Atlantic, knitted empires together with instantaneous coded dispatches. Society relied on copper wires and galvanic batteries, but had no legal or scientific concept of space weather. The stakes were elemental. Delicate electrical systems that underpinned commerce and daily life faced invisible celestial forces they neither anticipated nor understood. The coming days would expose that ignorance starkly. On September 1st, 1859, at about 11:18 a.m. from his Red Hill Observatory in Surrey, Richard Carrington trained his telescope on a large sunspot group and saw an abrupt, dazzling eruption. Two brilliant patches of white light bloomed within the spots, so intense that he made a precise sketch and timed notes, the first recorded visual observation of a solar flare. He recorded positions and times with the exactitude of a banker and the zeal of an astronomer, his careful strokes betraying equal parts excitement and bafflement. He communicated the finding to colleagues and to the Royal Astronomical Society, and the sketch later became key evidence linking solar outbursts to geomagnetic disturbances. By evening, unsettling reports arrived. Auroral curtains blazing at unusually low latitudes, telegraph equipment throwing sparks, delivering shocks, and in some places operating without batteries. The Carrington flash thus shifted from solitary wonder to ominous portent as the sun seemed to reach down toward Earth's wired empires. By the night of September 2nd, 1859, the brass-bound heavens erupted across the planet. Brilliant auroral curtains painted skies from London to Havana, dazzling people who reported crimson, emerald, and purple coronas that turned gas-lit streets into an otherworldly theater. Telegraph networks across Britain, France, Germany, the United States, and Canada went from marvel to menace as operators experienced violent electric shocks, flying sparks, and arcing currents that singed insulation and, in a few stations, ignited paper and enameled fittings. In New York and Boston, dispatchers reported messages still being transmitted even with batteries disconnected and instruments behaving like wild dynamos. Magnetometers at Kew Observatory in Greenwich registered extraordinary departures from the norm, and Sir Edward Sabine, comparing the disturbances, began to link Carrington's September 1st observation with this global geomagnetic tempest. Wonder hardened into practical alarm as railway telegraphy and financial tickers faltered, setting the stage for even harder reckonings. Investigators stitched together magnetometer traces, telegraph logs, and eyewitness testimony to turn a nocturnal wonder into a measured disaster. At Kew Observatory in Greenwich, magnetographs on September 2nd, 1859, registered sudden violent departures from the normal daily variation. Sir Edward Sabine correlated those records with reports of shocks and auroras pouring in from Britain, North America, and the Caribbean. Richard Hodgson's independent sighting at Red Hill confirmed Carrington's flash and supplied timing that pinned the solar eruption to the ensuing geomagnetic tumult. Later scientific reconstructions interpreted these clues as a blisteringly fast coronal mass ejection, a vast cloud of magnetized plasma that unusually crossed the Sun-Earth gap in roughly 17 to 18 hours. In plain terms, the passing cloud changed Earth's magnetic field rapidly. By Faraday's law, that changing field drove electric fields along long grounded conductors. Copper telegraph lines, galvanic batteries, and earthing practices became unintended antennas and return paths. So induced currents surged through instruments, producing sparks, shocks, and even battery-free signaling. That forensic arc made clear how solar fury could couple directly into gilded Victorian infrastructure. From the Kew and Greenwich records to today's lattice of pylons, a Carrington-scale coronal mass ejection, CME, striking now would drive huge currents into high-voltage transformers, saturating and frying long lead units whose replacements can take months. Dozens of transformers could be lost across regions, crippling transmission. Geostationary satellites would sputter or fail. GPS positioning could drift or vanish, grounding aviation and breaking logistics. Cellular networks would falter, financial markets would stutter without accurate timestamps, water and fuel pumps could lose power, and hospitals would be forced onto backup generators. The human impact would be immediate and brutal. Cold, dark cities, stranded patients, stalled commerce. Centuries of telegraphic wonder would be overshadowed by our pervasive dependence, forcing an urgent reckoning with infrastructure fragility. Carrington's spectacular 1859 storm kicked off modern space weather science, triggering magnetometer networks, solar physics research, and the first protocols linking solar eruptions to infrastructure risk. Today, that legacy requires sustained investment, better forecasting satellites and models, systematic grid hardening and transformer upgrades, clear operational protocols for utilities, and international cooperation to protect satellites, power, and communications. Act now. Fund forecasts, retrofit grids, and rehearse response plans. Mitigation won't eliminate the risk, but it can blunt catastrophe. Choose preparedness over complacency and back it with political will.